Hi everyone, I'm Hammad, and I'll just start with a brief intro. I'm a senior at the University of Richmond. I'm majoring in computer science and math, and I'm currently working from home from Richmond. And I'm a dev intern on the Adaptive Cards team. My manager is Shalini, and my mentor is Paul. So this summer, I focused on the problem of inconsistency. So to start off, I'll talk a bit about what inconsistency is. So put it simply, inconsistency is when a card payload behaves differently across the different platforms. So it might render differently on different platforms, or it might render on some of them, or fail to render on some of them. So we want the behavior to be consistent across all the platforms. So we want it to render consistently or fail consistently on all of them. And so to test if your a card payload is consistent, you have to basically manually render the card on each of our supported platforms. And to do that, you have to basically use some of the tools that we ship. So for .NET and UWP, these are the visualizer tools. For JavaScript, this is the designer, and for Android and iOS, these are the apps that we ship. But the inconvenience from these tools is that some of them build against our source code, not our publicly shipped rendering SDKs. And also, they're not easily available to everyone. So, for instance, if you wanted to test for iOS, you would need a Mac to build the app and all. So this is where my project comes in. I created this project called Consistent Cards. It's a web-based application that provides a quick and easy solution to test the consistency. So the user is basically inputting a JSON payload that corresponds to an adaptive card, and the user clicks submit, and then they're able to see pictures of their card rendered across some of the platforms that we support. And at the back end, it is using the rendering SDKs that we ship publicly to take that card payload, parse it, and render it on each of the supported platforms. So currently, this project works for UWP, Android, JavaScript, and .NET WPF. And it's actually quite useful for our adaptive cards team for testing, and it's also quite useful for our customers and clients to test their card payloads across multiple platforms and see how they look like. So let's dive into how this project is actually working, and I'll talk a bit about the architecture and a bit about the details of request handling, and then I'll show a demo and wrap up with some Q&A. First, let's dive into how this works. We start off with a user who has a JSON payload corresponding to an adaptive card. The user inputs this payload to the front end of the web interface, and this front end communicates with the backend REST endpoint and sends the user's inputted JSON to the backend. And then this backend is connected to a bunch of cloud-hosted REST API, each written in Python Flask. So the REST endpoint basically sends the user's inputted JSON payload to each of these REST API via HTTP post. And then each REST API is connected to a driver program corresponding to each platform that my project supports. And so the REST API sends the user's inputted JSON payload to this driver program. For JavaScript and .NET, it starts the driver program as a child process and communicates over standard in and standard out. For UWP and Android, these apps are REST apps, so the REST API just sends a post request to these driver apps as well. And now this driver app basically parses that payload, and then it renders the adaptive card using the rendering SDK, and it takes a screenshot of the card. It converts that screenshot to a base64 encoded string, and then it sends back the base64 encoded string as well as any warnings or errors that were generated during the rendering. And then these are communicated back to the REST endpoint, and then these are finally shown to the end user. Here are some of the details of how the request handling works. So as I explained earlier, the user inputs a JSON data for the card, and the web interface sends this JSON to the Flask app by HTTP post. The Flask app sends it to the driver program via standard end, and then the driver program parses the JSON, renders the adaptive card, takes the screenshot, converts it to base64 encoded string, and sends it along with warnings and errors. And then the Flask app sends this back to the web interface, and the web interface shows this to the user. And so for UWP and Android, it's pretty much similar, except in this case, the Flask app is communicating with the driver program via HTTP post, and it gets an HTTP response back. And so now I'll show you a quick demo of how this project is actually working. So here you can see the front end of the web interface. So as you can see, as allowing the user to enter the card data and a card template. So to start off, I'll try it with a non-templated card. So I'll just copy this card. On the right, it's rendered using the JavaScript rendering SDK. So once I paste this payload here and I click submit, so I should hopefully be able to see this card across the platforms that we support. So as you can see, this is that card payload rendered using the JavaScript rendering SDK, the WPF, Android, and UWP. So this is the card payload, and it was actually rendered on each of these platforms, and a screenshot was taken. If there were any warnings or errors that were generated during the process, those would have been shown directly underneath. And you might notice some differences in the buttons, like so these are per platform, and that's just how this card looks like on Android. So these are per platform details. So now you may have noticed that we have data and template, and this corresponds to templating that we introduced in May. So my project currently supports both templated and non-templated cards. And to demonstrate that, I'll just take a quick look at this card and see how that renders. So I'll just copy the data and I'll copy the template. So a forewarning, currently we're not supporting templating on Android. So this card might look different on Android than you're expecting. So, yeah, so as you can see, I've just shown that templated card on across all of our platforms. Now you might be thinking why Android looks the way it does. And that's simply that we haven't yet introduced templating on Android. So if you do try to render a templated card on Android, then that is how it would look like. But in the future, when we do introduce templating on Android, it will look pretty much similar to the rest of the platforms. But it's pretty good that we can use both templated and non-templated cards. And in a way, you can actually see how the templated card would look like on Android if you tried. And so a bit about the future of this project. I'm currently focusing on the deployment right now. Most of it is working on my local machine, but that's what I'm focusing on. So one of the areas that I'm looking on is Docker containers, and another area that I'm looking into is these hosting services like Expo, Appetize, Test Cloud, where I can host my Android or Android UWP apps. And so another area that we do need to focus on is implementing the iOS part of this project. So if we do implement it, it will be quite similar to how Android and UWP work. And one of the nice features about the architecture of this project is that each piece that I showed you earlier is individual. So we can pick and choose which pieces that we want. And so in terms of that, it offers us the flexibility of using or taking some of the pieces of this project and using them how we want. So an example can be in our designer. Right now, you can just click preview and render the card using the JavaScript rendering SDK and see how it looks. But in the future, one of the areas can be that we can have a drop down or something where you can just place the card payload and just in the designer, you can see how it looks like across some of our platforms. And we are also thinking of incorporating it in our builds so that every time someone pushes code, it just renders some of our sample cards and shows you how that code that you pushed is it in breaking any changes or causing any weird behavior. So there are multiple venues where we can make use of this project.
Cool.
Yeah, that's most of it. So if you have any questions, do let me know.
Awesome. That is super cool to see, and the progress keeps getting better. A quick note on templating too. So one big piece of our roadmap that we're really hoping to land is to get templating working on the mobile SDKs by the end of the year, so that Android demo would start working, and it gets us towards where we can start having templating directly in apps like Teams, et cetera. So really cool.